The beauty is in the details. Threads in base materials. Man, threads and base materials are the bread and butter of machine design. And while it looks simple, it can get hairy very quickly. So this plate has 4 holes and 2 blind holes here to mount to the basic structure. Now, the way that you usually start and make threads, you start with a center drill, you move on to a drill, then you move on to a tap, and you finish it off with a chamfer. Move that to the side. Now, let's start with just a couple of questions. Why do you use a center drill? A center drill is used to make sure you hit right on the money every time when you come in with your drill. And what it is that it's pretty stiff, as well as it meets at a point. So what happens if I don't use a center drill? If I don't use a center drill, your regular drill may be dancing along. If it is just one of the main drills that you have that doesn't end in a point, which takes us to how to pick a drill. Drills come like people in different sizes, different lengths, different coatings, different features. Okay, this is a drill kit that is just for the number drills. There's another drill kit that I have that includes numbers, fractions, letters, and there's another one that I have that is metric. Lengths of the drill usually stay within the St. Vinay's characteristic dimensions. There are drills that are longer. There's also drills that are shorter. And this is going for manufacturing and machine design, both of them merged. Coatings, like this ones that you can see here, are also based for the materials. Are you cutting plastic? Are you cutting aluminum? Are you cutting stainless? They all have a feature to allow you to go longer tool life. Now let's get to the features. So drills can have different features at the top. And at the top you can have essentially a drill that incorporates both of these one on top of the other. So you minimize a process where you have to do a center drill on top of a drill. These are just features. There's also drills that are designed for cutting plastics, that are designed just for cutting steel. This gets into the science of material removal rate and manufacturing, the real depths and guts and details of it. How do you pick your drill? There are tap and clearance charts, and they'll tell you based on the material that you're going to use which drill you actually need. So if you're doing for aluminum, it's one drill. If you're doing for a steel or a plastic, they'll use other drills. Now you can also go to Machiner's Guide. The really fun thing, after you make your clearance hole, you're going to use your taps. Okay, these tools wear out, so note that. A good machine shop will keep track of the tool life and actually replace them. So if you're making 10,000 pieces, you know when to replace the drill, such that your drill starts essentially getting smaller over time. Now let's get into taps. Taps also come in a bunch of different shapes and sizes. The one thing that you're going to get a flavor for in taps is that they're tapered. About 2 critical dimensions, and that's using St. Vinay's principles of characteristic dimensions, the taps are tapered. And that's because when you do your drill hole or your clearance hole, you're going down, and as you go down you want to make sure to a little bit center, and then these features will cut the threads into the base material. This is also a tool that wears out, and one of the things that happens for through holes is that you can run the tap all the way down to the bottom and you get that even thread all the way throughout, such that you avoid just tapping at the beginning. You should go about this length in, or at least 3 characteristic dimensions in. So what if you can't? For some reason you can't go all the way to the bottom, or there's something else there. There you have these taps that are called bottoming taps. And essentially, after you begin the thread with this regular tap, you go ahead and they are basically flat here, and you can continue on that thread all the way so you get to the bottom. And you specify this in your machine drawings, in your part drawings. That's all good. Now we're in the taps. The one thing with taps that can also happen, in addition to wear, is that taps come in different size tolerances, and you can go to Machinery's Handbook and get the different flavor for, is it a 6H, is it a 4G or a 6G? All of these for taps have meaning. Okay, here's a simple thing as just getting a tap. Eventually we'll get into other taps like this specialty tab. It's called an NPT tab, which is tapered all the way throughout the thread. Okay, and that's gonna be a whole different lesson there. If you like this video, you know what to do. Give it a thumbs up, subscribe, follow me on Twitter at DARE2 make the number 1. Dare to make one.